Okay, in these last two examples, there'll be a structure in which we use as one side of any enclosure that we need to do. So, a heavy equipment operator has 200 meters of fencing to construct a rectangular storage area using a warehouse as one side. Write the quadratic function that models the rectangular region and use it to determine the maximum area. So, there's only 200 meters of fencing used this time, but one side of the fence is going to be taken up by the side of the warehouse. So in this case, we only have one length that we need to worry about here. The other length is taken up by the warehouse. So the width, we'll call that x. So it will be one there, one here. And now we need to develop our formula for length. So there's 200 meters of fencing. Take away twice our widths, and that's what we have left over. This is all that can be used for our length. So our 200 meters, take away twice the width. That's all we can use here for the length. So the area, and the area depends on the width. So the width times the length, 200 subtract 2x. So our formula is 200 subtract 2x squared. So our a value is negative, which means in terms of the graph, area, width, there is no y-intercept, so the graph starts at 0, goes up and comes back down. So we have to find our axis of symmetry, which will then be used to find our maximum area. So axis symmetry, we apply our formula, and then we'll go ahead and solve. Alright, so applying the axis symmetry formula, we find out that we get the maximum area at 50 meters. We then take the 50, plug it back into our equation, and find that maximum area is 5,000 meters squared. Now you can also look back up to your example without having to do that. Look at your diagram. So using 50 meters on each of the widths, so you used up 100 meters there. There's only 200 meters to begin with, so if you take away 100, leaves you 100 meters here for your length, and considering area is length times width, so if you multiply the 50 and 100 together, you will come back with 5,000 meters square. Alright, last example here. Rectangular region placed against the wall of a house, and in this example now we've divided it into two equal parts, and we only have a total of 150 meters of fencing. So your width here, here, and there are all the same. So now we need to find out what length is. So let x equal to width, and then the length. We only have 150 meters of fencing to start with. Let's take away our three lengths, 1, 2, 3. So take away our three widths, and this is what we would have for our length. So area is length times width, or 150 subtract 3x times x. 150x subtract 3x squared. So our area in terms of x is here, given by this equation. The a value is negative. So for your area and your width, the y-intercept is 0. As you look at the equation, there is no constant term. So we're going to find the width that gives us the maximum area, and then we can use that to get the maximum area. So find the width first here, and second, we'll use that to find our area. Okay, so using the axis symmetry formula, we find that the maximum area occurs with a width of 25 meters. Putting the 25 meters back into our equation, So we see X, we put the 25 meters in. We find that the maximum area is 1875 meters square. And again, you did need to work this step out completely, or you can always check it by putting your width back in. So you had 3 widths, each were 25. So you used up 75 meters out of the 150 just on the widths. So there's only 150 to begin with. We just used up 75. So 75 meters left. So area calculation, 25 times 75 should give us 1875.